Significant figures and uses. Significant figures are an important concept in science and engineering, as they help us to express measurements and calculations with appropriate precision and accuracy. Essentially, significant figures are the digits in a number that are meaningful or relevant, and they are used to communicate the level of certainty or uncertainty in a measurement or calculation. There are different rules for determining the number of significant figures in a given number, depending on the context and the type of measurement being made. However, some general guidelines include: non-zero digits are always significant. For example, the number 1.23 has 3 significant figures, because each of the digits, 1, 2, and 3, is non-zero and therefore relevant to the measurement. Zeros at the beginning of a number are not significant. For example, the number 0.0001 has only one significant figure, because the leading zeros are not relevant to the measurement. Zeros between non-zero digits are significant. For example, the number 10.01 has 4 significant figures, because each of the digits, 1, 0, 0, and 1, is non-zero or between non-zero digits. Zeros at the end of a number may or may not be significant, depending on whether they are significant in the context of the measurement. For example, the number 1.00 may have 3 significant figures if the zeros are meant to indicate a high level of precision, or only one significant figure if the measurement is less precise. The number of significant figures in a measurement or calculation is important because it can affect the accuracy and precision of the result. For example, if you measure the length of an object to be 12.345 centimeters, you should report the result with 5 significant figures to convey the full level of precision. If you perform a calculation using that measurement, you should carry the appropriate number of significant figures through each step of the calculation to avoid introducing errors or inaccuracies. Overall, significant figures are a useful tool for communicating the level of precision and accuracy in scientific and engineering measurements and calculations. Can you tell me more? Sure, I'd be happy to provide some more information about significant figures and their uses. One important application of significant figures is in the reporting of experimental data. When scientists or engineers perform experiments to measure physical quantities, such as length, mass, temperature, or time, they need to report their results in a way that reflects the precision of the measurement. This is where significant figures come in. For example, suppose you measure the length of a metal rod using a ruler and obtain a result of 3.21 centimeters. In this case, the significant figures are the digits 3, 2, and 1, and the final reported result should have 3 significant figures to reflect the precision of the measurement. Therefore, you would report the length of the rod as 3.21 centimeters, rather than simply 3 centimeters or 3.2 centimeters, which would not convey the full level of precision. Similarly, if you perform a calculation using measured values, you need to carry the appropriate number of significant figures through each step of the calculation to avoid introducing errors or inaccuracies. For example, suppose you want to calculate the volume of a rectangular box with dimensions 3.21 centimeters by 2.45 centimeters by 1.83 centimeters. To calculate the volume, you would multiply the 3 dimensions together. V equals L x W x H equals 3.21 centimeters by 2.45 centimeters by 1.83 centimeters equals 14.277315 cubic centimeters. However, because the dimensions have different numbers of significant figures, you need to round the final result to the appropriate number of significant figures. In this case, the dimension with the least number of significant figures is 1.83 centimeters, which has 2 significant figures. Therefore, the final result should be reported with 2 significant figures, V equals 14 cubic centimeters. Another application of significant figures is in the propagation of uncertainties. When you perform a calculation that involves measured values, The uncertainty in the final result depends on the uncertainties in the measured values. The rules for propagating uncertainties involve taking into account the number of significant figures in each value and rounding the final result to the appropriate number of significant figures. This helps to ensure that the uncertainty in the final result is reported accurately and appropriately. In summary, significant figures are an important tool for communicating the precision and accuracy of measurements and calculations in science and engineering. They are used to report experimental data, carry significant figures through calculations, and propagate uncertainties. By using significant figures correctly, scientists and engineers can ensure that their results are communicated accurately and appropriately, and that the level of precision and accuracy is clearly conveyed to others. Now I want to know more. Explain. Another application of significant figures is in the propagation of uncertainties. In more detail in the next video. Please like and subscribe for more fun stuff. Hope you found some value in this video.